Hello viewers, welcome to this learning dialogue on the cerebellum. At the end of the session, the student should be able to tell location and relations of cerebellum, describe the external features of cerebellum, name the parts of cerebellum, tell the morphological and functional divisions of cerebellum, know the connections of the cerebellum, name the nuclei of cerebellum, and give the functions and clinical importance of cerebellum. Let us begin with knowing about the subdivisions of cerebellum. The cerebellum consists of a median vermis connecting the two cerebellar hemispheres. There are two cerebellar hemispheres, one left and the other right. The two cerebellar hemispheres or the cerebellum is divided into a superior and inferior surface by a horizontal fissure. The superior surface is above the horizontal fissure and the inferior surface is below the horizontal fissure. On the superior surface, there is a primary fissure that divides the cerebellum or cerebellar hemispheres into cerebellum into anterior lobe and the middle lobe. On the inferior surface, there is another fissure called posterolateral fissure that separates the middle lobe from the flocculonodular lobe. So there are three fissures. One is horizontal fissure that separates the superior and inferior surfaces. Primary fissure on the superior surface that separates anterior lobe from middle lobe. Posterolateral fissure that separates flocculonodular lobe from the middle lobe. The vermis is divisible into many subdivisions. The subdivisions are the lingula, central lobule, culmen, declive, folium, tuber, pyramid, uvula, and the nodule. These are the parts of vermis. The parts of vermis are lingula, central lobule, culmen, declive, folium, tuber, pyramid, uvula, and the nodule. The subdivisions of cerebellar hemispheres are there is ala and quadrangular lobe. These two are present in front of primary fissure in the anterior lobe. The simple lobule and the superior semilunar lobule are present in front of horizontal fissure on the superior surface and behind the primary fissure. The inferior semilunar surface, semilunar lobule, biventral lobule, and tonsil and flocculus are the lobules present on the inferior surface. Now we can see the morphological and functional divisions of cerebellum. The nodule, flocculus form flocculonodular lobe, and the lingula of anterior lobe will form the archicerebellum. The first to form in development, which is vestibular in connection and responsible for control of axial musculature, thereby helping in locomotion and equilibrium. Paleocerebellum is second part of cerebellum to develop. It consists of ala and quadrangular lobule, central lobule, and culmen of the vermis of anterior lobe. The paleocerebellum consists of anterior lobe minus, that's lingula, which is part of flocculon, which is part of archicerebellum, plus the pyramid and uvula of the middle lobe will join with ala quadrangular lobule, central lobule, and colbun to form what is called as paleo-cerebellum. The paleo-cerebellum is spinocerebellar in connections and is responsible for muscle tone, posture, and crude movements of the body. Then we have a neocerebellum. The neocerebellum consists of middle lobe, most of the middle lobe, simple lobule, superior semilunar, inferior semilunar, biventral lobule, and tonsil, parts of the hemispheres, and decline, folium, tuber of the vermis will form the neocerebellum. The neocerebellum consists of middle lobe minus that pyramid and uvula, which are part of the paleocerebellum. They are cerebral in connections, so they are last to develop, recently developed, so called the neocerebellum, and responsible for fine movements of the body. The gray matter of cerebellum consists of nucleus fastigii, nucleus globosus, nucleus emboliformis, and the nucleus dentatus. Nucleus fastigius, nucleus globosus, nucleus emboliformis, and nucleus dentatus are the gray matter or nuclei of the cerebellum. The cerebellum has superior cerebellar peduncles that mostly connects it to the tectum and the forebrain, middle cerebellar peduncle, which is the connection between the pons and the cerebellum, and inferior cerebellar peduncle is mostly connecting the spinal cord with the cerebellum. The afferent and efferent tracts are given in the table. The superior cerebellar peduncle receives fibers of anterior spinocerebellar, tectocerebellar, dento-olivary, and fastigio-reticular, while it gives out the cerebello-rubral and dendritothalamic fibers. The middle cerebellar peduncle is purely afferent in nature. It receives fibers only from pons, and the fibers are part of the cortico-pontocerebellar pathway. The inferior cerebellar peduncle has a wide range of connections. That is, afferents are coming from posterior spinocerebellar, cuneo-cerebellar, olivocerebellar, paraolivocerebellar, reticulocerebellar, vestibulocerebellar, and anterior external arcuate fibers, stria medullaris, and trigeminocerebellar fibers. It gives out some efferents which connect cerebellum to the vestibular nuclei, that is cerebellovestibular, cerebellum to olivary nucleus, cerebello-olivary, and cerebello-reticular fibers are the efferent fibers. The functions of cerebellum. The cerebellum controls the same side of the body, so the connections are ipsilateral, helps in coordination of voluntary movements so that they are smooth, balanced, and accurate. This is mostly done by the neocerebellum. The muscle tone, posture, and equilibrium are controlled by the axillary musculature controlling archicerebellum, and the muscle tone and the posture are controlled by the paleocerebellum. Equilibrium is controlled by archicerebellum, and tone and posture are controlled by the paleocerebellum. If cerebellum is damaged, or the clinical effects of cerebellar dysfunction are called as cerebellar syndrome. It results in muscle hypotonia. The muscle tone is lost. Loss of muscle tone will result in what is called as tremors. These are intention tremors, means when you are attempting to do something, there is a shaking in the limbs. Adiadokinesia. The patient, when asked to perform the supination of the forearm like this, we will not be in a position to do it. The oscillatory movement of the eyeballs is called nystagmus. And scanning speech, the person will not be able to spell the word perfectly. He will spell each of the letters in a word. That is called as scanning speech like this. And ataxic gait will not be able to travel or walk on a straight line. These are called as cerebellar syndrome symptoms. So thank you for watching.